G'day. I hope you've just watched my last video about the ancient Babylonian differencing technique and W. Sawyer and his search for pattern, and how all of this is tied up with polynomials. In this particular video, I'm going to show you how to construct a polynomial equation to give a series of results. Okay, what are the gaps? 2, 4, sorry, I'm jumping ahead of myself. 2, 2, 2, 7. 0, 0, 5, 0, 5, 5. This is simple enough, isn't it? So here is our leading row of numbers. And our formula, let's use x and y. Our formula is going to be y equals 0 times xc0 plus 2 times xc1 plus 0 times xc2 plus 0 times xc3 plus 5 times xc4. So there we go, 0, 2, 0, 0, 5, 0, 2, 0, 0, 5, and the pattern is xc0, xc1, xc2, xc3, xc4. Now the nice thing here is that because we have coefficients of 0, these terms are not going to contribute to our result at all. So what is our answer going to be? It's going to be 2 times xc1 is just an x over a 1 plus 5. Now because I'm going to, I would like to write it under here, but we'll write it over here. 5 times. Now xc4 is going to have x, it's going to have 4 terms on the top, minus 1, minus 2, minus 3, 1, 2, 3, 4, over 4, 3, 2, 1. Which equals 2x, that part's easy, plus 5 times this. Now, on the bottom we have 5 does not divide into this. 4 times 3 times 2 times 1 is 24. And we have x times x minus 1, x minus 2, x minus 3. Now, what I did when I did this for the teacher was, I think we went further and I was down to a 5th power or something like this. You can see this is a 4th power, x times x times x times x. I expanded it all and gave them this long expanded expression. But this will do. Just notice, substituting x equals 0 is easy in this, 0 and 0. So y equals nothing. That works. Let's tick these off, or check these off as we go. If I put x equals 1, well, if I put x equals 1 in here, this becomes 0, doesn't it? So the whole term is 0. X equals 1 in here, y equals 2 1s are 2. If I put x equals 2, this is 0, so the whole term here is 0. And 2 times 2 is 4. If I put x equals 3, 3 minus 3 is 0, 2 3s are 6. If I put in 4, there is no x minus 4 term, so I've actually got to substitute. So let's find the y value when x is worth 4. It's 2 lots of 4, plus 5 times 4 times 3 times 2 times 1, because when x is 4, 4 minus 1 is 3, 4. This is following the factorial pattern, over 24. Now 4 times 3 times 2 times 1 is 24. 4 3s are 12 times 2. So all of that divides that, and I get 2 3s are 8, plus 5 13. Look at that. Please go exploring. You can actually find, provided it's a polynomial, that you can generate a polynomial equation for any set of numbers, provided they're lined up under 0, 1, 2, 3, 4. That was a lovely discovery at 15 years of age from this book, which I mentioned in the previous video, The Search for Pattern by W. W. Sawyer. Let me write his name up. There's actually a website. Actually, go to the website, www.sawyer.org. And he only died in 2008. I wished I got in touch with him to tell him how much his books inspired and impressed me. Wonderful, wonderful writer. Let me encourage you to track him down. He wrote books like The Search for Pattern, A Mathematician's Delight, which was, I think, his first book, which sold something like 5 million copies. Probably the best-selling mathematics book ever. Remarkable. Can't say enough about him. New Zealander, from not far from Australia. But he died in Canada. But I guess I'm sharing this to say not all problems are resolved using this, only polynomial problems. So I'll leave it at that. I'm going to produce one more video to show how the Babylonian differencing technique does unlock another class of problems that are not polynomials, but I'll leave it for you to log on and have a look at that at another time. In the meantime, if you've enjoyed this and you'd like to see more, then please subscribe if you're not already a subscriber. And as always, I'd encourage you to leave a comment. I'd very much enjoy your feedback, whether it's positive or negative, or whether you can suggest other things to do. And please like the video. That always helps. As always, I thank you for watching.